see if I can do this. Okay, so multiple choice questions. The first one was about tides. The moon, of course, causes tides. And we have kind of those diminished tides, or what we call neap tides, E. When we have the quarter moons, the first and third quarter. So E is the best answer for one. Question 2. Of the ways matter and energy react or interact, D is not one of them. So evaporation is not a way that they interact. Question 3, I was actually after, I gave you the library sample of hydrogen. One particular spectral line was at 121.6 nanometers. Let's see, the spectrum. Okay, and the star actually is a little bit longer wavelength, 121.8 nanometers, a difference of 0.2 nanometers. I was after like a redshift is occurring. So the best answer there is D, that we can tell that the star must be moving away from us because of that little bit longer. The spectral line has moved over. Question 4, if you heat a gas so that the heat a gas so that the electrons are promoted to a higher energy level. When they fall back down, they are going to produce B, an emission line spectra. Question 5. Suppose you see two stars, a red and a blue one. What can you conclude, assuming that there's no Doppler shift involved? And that's E, that the blue star has a hotter surface temperature than the red star. And actually, this ended up as a short answer question at the end, too. Question 6, according to the theory of the formation of our solar system, why we find exceptions, the best answer there is C, because of basically impactors kind of roaming the solar system, who tilted the Earth, caused our moon's formation, tilted Uranus and Venus. Frequency, this was one where actually I went back and hand checked it. The best answer for this actually is E, all of the above. But as you can kind of see the whited out area, I picked A right off the bat, but it's true that frequency actually is measure of cycles per second. It's also true that we're looking at peaks passing any point per second, and actually C and D are also true about frequency, so E is the best answer there. Question 8 is a question about mass, and we said that mass is actually the same if you're on the Earth or the moon, and so a lot of people got this, so D is the best answer. Your mass would be the same. Question 9, Voyager continues to speed out of the solar system. I didn't think it's Voyager 10, it's Voyager 1 and Voyager 2. I don't know where that 10 came from. But the fact that any spacecraft basically goes in a straight line without propulsion is a good example of A, Newton's first law of motion. Question 10, if we look at Einstein's E is equal to mc squared, basically A, what all stars do this, they take a tiny bit of mass and they convert it into a large amount of energy. So A is the best answer there. Question 11 and 12, I kind of have squiggly marks there. I don't know, squiggly marks because I think, well, the A was probably not worded as I would want it to be worded. The best answer is basically, 11 says, suppose an object is moving in a straight line. According to Newton's first law, the object will D continue to move in the same way until it's acted upon by a force. I wasn't real thrilled with the way that, they call them distractors, A, B, and C are distractors were written. Question 12, I don't know if I actually emphasized this in our review session, but we said that if you are given the atomic mass number of an element, number 56 in this case, that's the number of protons plus neutrons. Atomic number is the number of protons. So actually then we can knock out protons, neutrons, and electrons for this iron atom, assuming it's neutral. So 26 protons in its nucleus accompanied by 30 neutrons. We get the 30 by difference. We take 56 minus 26 to get 30. And then 26 electrons if it's neutral. So I wasn't real thrilled about that one. Question 13, the tides on Earth are an example of D, the Newton's universal law of gravitation. Answer there. Question 14, the force due to gravity actually will decrease as the distance increases. So B is the best answer there. 15, which of the following is not a characteristic of an inner planet? It's not true that they have substantial atmospheres. This actually, and I know Adam mentioned it, this, if I had it to do over again, I probably, instead of putting the word satellites, I probably would have put lowercase moons, okay? So, of course, the inner terrestrial planets don't really generally have the moons that the Jovian planets have. Question 16, which of these list the ingredients of our solar nebula from most abundant to least abundant? The answer there is C. Light gases were far abundant, followed by our hydrogen-containing compounds, and then rocks and metals. Question 17. Angular momentum depends upon mass, velocity, and radius is the best answer there. Question 18, the fact you can see any object, including us, is because light is reflecting off of an object. B is the best answer for 18. Question 19, where did those large moons around, for instance, Jupiter and Saturn come from? And that was that little inset kind of from our solar nebula. That best answer is at C, that they were formed by their own little accretion disks around the planet. Question 20, why did the solar nebula heat up as it collapsed? That's an example of gravitational potential energy converted to thermal energy. So C is the best answer there. Oh. Question 21. We talked about telescopes, and we said actually when you're dealing with radio astronomy, you need to have very large telescopes. So that's the best answer there, B for 21. Or use interferometry or both. Question 2, based on our current theory of how of Earth's overall formation, our drinking water, C, came from comets. Question 23, which of the following are relatively unchanged fragments, basically leftovers from the formation of our solar system? And the answer there is D, all of the above. We'll do a whole chapter on that stuff coming up. Question 24, from the lowest to the highest energy, A, list them: radio, infrared, visible, UV, X-rays, and gamma rays. Missed microwaves, but that's okay. Question 25, the meteorites, actually we can date them, using isotopes and decay of potassium into argon. And we can see that B, that the age of our solar system is about 4.55 or 4.6 billion years old. That's our solar system. Question 26, the wavelength of a wave, best answer there is D, the distance between two adjacent peaks of the wave. Question 27, where do we find most asteroids in the asteroid belt between Mars and Jupiter? A is the best answer for 27. 28, where did elements that are heavier than hydrogen and helium come from? Actually, stars manufactured them, so D is the best answer there. Last two multiple choice questions. The gaseous or Jovian planets, the major constituent is E, hydrogen and helium. Question 30, which of these about thermal radiation is always true? It's always true that B, a hot object will emit photons with a higher average energy than a cool object. So the next ones were vocabulary. So Pluto is now designated a dwarf planet. Question 32, I was after mass is the amount of matter an object contains. Question 33, I was after planetesimal, is basically kind of a precursor to a planet. Okay. Question 34, I would take either frost line or asteroid belt. I was really after frost line as the thing that's between Mars and Jupiter that kind of explains why we had inner terrestrial planets and outer gaseous planets. Question 35, I was after isotopes. If you have atoms with the same number of protons, but they differ by the number of neutrons. Question 36, it's a refracting telescope that use lenses. In some cases, I gave you 1 out of 2 points. Like, for instance, if you put a reflecting telescope, I gave you 1 of 2. I was after spring tide, is that extra high tide that occurs when the moon is either in its full or its new phase. Question 38, kinetic energy is energy associated with motion. Question 39, absorption spectra or dark line spectra are created when actually an electron goes from a lower to a higher energy state. And the last page looks like this. Question number 1, I wanted to, in some cases I did not give you a hard time. For instance, I wanted units of acceleration, I think across the board. If you defined speed, velocity, and acceleration, I didn't give you a hard time about it. Okay, so, but units of acceleration are meters per second squared. Question 2, I wanted you to state Newton's 3 laws. So I'll just kind of leave that to you. Question 3, given 2 stars, and we'll be talking more about this, but like hot stars or cool stars. The hot star here is 8,000 Kelvin. The cool star is 4,000 Kelvin. Now these would be surface temperatures of the stars. I wanted you to give me 2 ways in which they differ. And so the hotter star will appear brighter, and actually it will have, its wavelength will be shorter wavelength. So it will have kind of a bluer appearance. The cooler star will appear redder, longer wavelength, and it'll be dimmer. For the next one, I wanted you to, I took a kind of an assortment of answers here. And most people, I don't think anybody really got what I really for sure wanted, okay? But a lot of times you explain the Doppler effect, and that's great. That was what I was after. And then specifically, I kind of wanted you to consider something that's blue shifted. And a lot of times you said blue shifted, it must be moving toward me, okay? But one of the things that we know is that if you take radio waves, and if you make radio waves shorter and shorter and shorter, the next would be microwaves. If you take microwaves, apply a blue shift, you can actually shorten them to the point of being infrared. Okay, you shorten those, you can make them be visible. Okay, so that's kind of where that is. For number 5, again, I wasn't too picky. Some of you did it great, but some of y'all just kind of forgot to. Part of it was to list which planets are which planets are terrestrial, which planets are gaseous. So if you see this on a final, beware. I want you to list them. That's the last part of the question. The first part of the question is to kind of compare and contrast. And with regard to size, we definitely have small versus large. Composition, rocky versus gaseous. Moons, not so many moons, lots of moons for the gaseous planets. Rings, no rings for the terrestrial planets. And basically, all the gaseous planets have rings, even though we think Saturn is having the coolest rings. Okay. Then the last one, I wanted you to kind of describe what asteroids and comets are. I said the word leftovers a lot, so that's good. Leftovers from the formation of our solar system. How are they, how and why are they different? So they're different because they formed in different parts of our solar system. So the asteroids would be kind of formed inner with the terrestrial planets, and then the comets would be on the other side of the frost line. So, yeah, not too bad.